For this last match problem, I got myself off to a bit of a head start here, since a number of these steps are a little repetitive. So we started off by verifying the conditions here. We take the limit of e to the 2x, that's headed to infinity. The limit of x squared is also headed to infinity, in both cases where x is heading to infinity. So the conditions are met, and we can evaluate the derivative of each of our two functions, which means the limit as x approaches infinity can be rewritten as 2e to the 2x over 2x. So 2 over 2 is going to cancel, leaving us with the limit as x approaches infinity of e to the 2x over x. So as x gets larger and larger, e raised to some power is headed to infinity, x is headed to infinity. So again, we've got infinity over infinity. The conditions are met to apply a second iteration, a second iteration of L'Hopital's rule. So we'll again differentiate our two functions. We'll take the derivative of e to the 2x, which will give us 2e to the 2x, and we'll take the derivative of x, which will give us 1. So now our limit problem becomes the limit as x approaches infinity of 2e to the 2x over 1. 2 times e to the 2x, as x is getting larger and larger and larger, is headed to infinity, and so that's our limit. So again, with these L'Hopital's rules problems, or with any limit problem, in order to apply L'Hopital's rule, we first need to make sure those conditions are verified. After applying it once, we may find ourselves at a point where we end up with 0 over 0, plus or minus infinity over plus or minus infinity, in which case another iteration of L'Hopital's rule is going to be required, or it could require a third or fourth iteration, probably for most of our problems at most 2. But we can apply this procedure multiple times until we finally get to a limit problem that we can evaluate directly.